All right, I figured it would be easier instead of just sending a key to explain this problem, just in case you need a little more help. So the first thing I see here is that I have a base of 1/2. Whenever I have a base of 1/2, I want to think if I multiply something by 1/2, is that value going to get larger or smaller? If I multiply something by 1/2, that is definitely getting smaller, which means that this is a decay. Some of you said that, oh, it's a fraction, so it's decay. That's actually incorrect. Let's pretend the same problem said 3/2. I'm going to think through the same process. Oops, it needs to be an exponential. If I multiply something by 3/2, well, 3/2 is actually the same thing as 1.5. That's growing, not decaying. So be really careful with that explanation. It's actually incorrect. Okay, so I know it's going to be a decay. Then I look at my transformations. I have two transformations here. One is that negative. Negative means it's a reflection over the x-axis. And then the next one I see is that 4. And that 4 is going to be a vertical stretch. Okay. Before I even do that, though, I need to find my points. So remember, you always have to use the point 0, and then use at least one negative and one positive. I'm going to do 2 positives just because you might have used the value of 2. So I'm going to raise 1/2 to all of those exponents. So I'm really just putting that x in for the x of the equation. And this is important to show on your assessment. Make sure you know how to get your points. So 1/2 to the -1. Whenever you have a negative exponent, it needs to be the reciprocal. 1/2 to the 0, anything to the 0 is 1. 1/2 to the first is just 1/2. And then 1/2 squared is 1/4 because 1 squared is 1, 2 squared is 4. And now I'm going to take all of those points and do my transformations. So I have -1 and 2, 0 and 1, 1 1/2, 2 and 1/4. So the first thing I said was a reflection. So since that's on the outside, I'm going to change all of my y's. Anything outside changes the y, anything inside changes the x. And with exponents, we really don't change the x in Algebra 1. You will in Algebra 2. And then I'm going to stretch by 4. And then those are my final points, just because that's all my transformations are done. Every single exponential function has a horizontal asymptote. So when I graph these points, 1, -1, -8, 0, -4, 1, -2, 2, -1, I see that this side is really getting close to 0. We do have to graph that. So then I see this nice little curve for the exponential. Exponentials are never quadratics, and they are never lines. So back at the very beginning, I explained one way you can think of this as a decay, just because if I multiply something by 1/2, it's going to get smaller. The other option that you can say is this graph is a decay because as we go left to right, our function gets closer to the horizontal asymptote. So if I read left to right, I'm getting really close. I'm going to do that one more time. I start far away, and I get closer to the asymptote. So I could say that this is a decay because as the function, the graph, whatever you'd like to say, goes left to right, the distance. And some of you guys used this and said from y equals 0. You could also say the horizontal asymptote, because that's actually what it is getting smaller. So either way, you could talk about the base or talk about the distance from the horizontal asymptote. It has nothing to do with the negative. It has nothing to do with the 4. It is all about the base, just like Meghan Trainor.